Okay, so the concept under discussion is ionic bond. So bit of for ionic bond, you need to define ionic bond for exam viewpoint. Ionic bond is the bond formed by the complete transfer of electron from metal to non-metal, right? Bond formed by the complete transfer of electron or more than one electron. So complete transfer of electron or electrons from metal to non-metal, metal to non-metal. So ionic bond will form between metal and non-metal. You know that metal loses electron and gets positive ion, and non-metal gains electron and makes negative ion. So positive ion and negative ion they stay together through electrostatic force of attraction, which is actually ionic bond. For example, if I take NaCl, right? So sodium's proton number is 11 and chlorine's proton number is 17. So if I consider the general electronic configuration for sodium, the general electronic configuration is like this, and chlorine's general electronic configuration is like this. So now you can see that sodium has one valence electron and chlorine needs one electron in its valence shell. So ये जो sodium का electron है, it will be transferred from sodium to chlorine. As a result, we will have sodium ion like this. This is Na, is one positive ion, and the inner shell becomes valence shell. जब एक electron lose हो जाएगा sodium का from the valence shell, then the inner shell becomes valence shell like this. On the other hand, chlorine becomes chloride by gaining one electron. So I'm taking the valence electrons in account. So chlorine has 7 valence electron and one gained from sodium. So this is how we need to show the dot and cross diagram. Now, an electrostatic force of attraction will be present here between this positive and negative ion. So this electrostatic force will hold these two ions together. And this electrostatic force is actually ionic bond. Ionic bond is this very force between this positive and negative ion. So it may be asked to indicate nature of force in ionic bond. Nature of force for 2 marks, right? So for nature of force, you need to write electrostatic force of attraction, electrostatic force of attraction. 1 mark is for this statement between positive and negative ion. The other mark is for this statement, positive and negative ion. This is the nature of force which is present in ionic bond. Okay, so for exam viewpoint, you need definition for ionic bond, and you need to know that what is the nature of force in ionic bond. And the third thing which you need to know is dot and cross diagram. Dot and cross diagram, right, for ionic bond. So before making dot and cross diagram, you need to confirm that the bond present is ionic bond. And how would you confirm? If the bond is there between metal and non-metal, then the bond will be ionic bond. Bond between metal and non-metal will be ionic bond. So before making dot and cross diagram, you need to confirm that either the bond is ionic or covalent. So if it is ionic, then you need to go for dot and cross diagram like this, like I just made for sodium chloride. And and this one is magnesium oxide, and then this one is aluminum nitride. Okay. And so now how to make dot and cross diagrams for these 3 compounds? Let us take this sodium chloride as sodium fluoride. So if I write the general electronic configuration for sodium and fluorine, so it is like this: 2, 8, and 1 for sodium, and 2 and 7 for fluorine. So what happens that 1 electrons from the valence shell of sodium will transfer to the valence shell of fluorine. So as a result, sodium becomes sodium ion like this. This becomes sodium ion. The valence shell is gone. So that is why I'm showing the inner shell, which has 8 electrons. And fluorine, on the other hand, becomes fluoride like this. So fluorine has 7 valence electron, or 1 electron will be taken from sodium. So this is dot and cross diagram of sodium fluoride. As far as magnesium oxide is concerned, magnesium's proton number is 12, Oxygen proton number is 8, so the general configuration is 2, 8, and 2. For oxygen, it is 2 and 6. Now, what happens? The 2 electrons from the valence shell of magnesium will transfer to the valence shell of oxygen. So then magnesium becomes dipositive ion. This is magnesium, it is dipositive ion. Its valence shell is gone, and the inner shell is now the valence shell, which has 8 electrons. And the oxygen, on the other hand, becomes oxide, will become oxide. So oxygen has 6 valence electrons like this. So 2 electrons, which are represented with this dot, are from magnesium, transferred to this oxygen. So this is dot and cross diagram of magnesium oxide. Okay, so if I consider aluminum nitride, so aluminum's proton number is 13, nitrogen's proton number is 7. So the general configuration is 2, 8, and 3. For nitrogen, it is 2 and 5. So what happens? These 3 electrons from the valence shell of aluminum will transfer to the valence shell of nitrogen. So aluminum becomes tripositive ion, like this. This is tripositive with 8 electrons in the valence shell now. And the nitrogen, which had 5 electrons in its valence shell, 3 electrons from aluminum transferred here, and now nitrogen becomes nitride. These are the dot and cross diagram for the 3 ionic compounds you have. Okay, so now the attractive force between this positive and this negative will be electrostatic force. This is electrostatic force. Now this very attractive force is also known as electrostatic force. And this electrostatic force is actually ionic bond. Now here electrostatic force is present, which is actually ionic bond. Okay, so now which of these ionic compounds has greater melting point? अगर ये क्वेश्चन पूछें कि इन ionic compounds में किसका melting point ज्यादा है, तो you can mutually compare that aluminum nitride has greater electrostatic force between tri-positive and tri-negative ion. +3 and -3 ions will have greater electrostatic force as compared to sodium fluoride. Sodium fluoride में less होगी electrostatic force. So melting point will be greater for aluminum nitride because जहाँ electrostatic force of attraction will be greater, their melting point will be greater, right? So melting point of ALN, aluminum nitride, will be greater than the melting point of magnesium oxide, which will be greater than melting point of sodium chloride, right? Because aluminum nitride में electrostatic force will be greater, 3 plus and 3 minus. The magnesium oxide में electrostatic force will be less than aluminum nitride, or for sodium chloride में electrostatic force will be even less, right? So electrostatic force of attraction between ions वो melting point of ionic compounds को affect करेगी, right? So melting point ionic compounds में वो depend करेगा electrostatic force of attraction between the ions. As far as some of the other dot and cross diagrams are concerned, so for sodium oxide, how to make dot and cross for sodium oxide? You know that sodium has proton number is 11, so it's 2, 8, and 1. And oxygen, on the other hand, with proton number 8, is 2 and 6. So one sodium will lose 1 electron, and sodium becomes unipositive ion like this. But in the formula, we have 2 sodium atoms, so that is a better place 2 here. And oxygen has 6 valence electrons like this. So 2 sodium atoms together will lose 2 electrons. Okay, 1 oxygen atom will gain those 2 electrons. So this is dot and cross diagram for the sodium oxide. Now you can notice here that the total positive charge is +2 and the total negative charge is -2. So the net charge should be 0. Okay, only then your dot and cross diagram will be correct if the net charge happens to be 0. Okay, now if I take magnesium fluoride, so magnesium fluoride, magnesium's general electronic configuration is 2, 8, and 2, as proton number of magnesium is 12, and fluorine's proton number is 9, so general configuration is like this. So one magnesium will lose 2 electrons because it has 2 valence electrons. So magnesium becomes dipositive upon losing 2 electrons, and those 2 electrons will be adjusted with 2 fluorine atoms. Each fluorine has 7 valence electrons. So one fluorine will gain 1 electron to get 1 minus sign. or one minus charge. So two fluorine together will gain two electrons, which are lost by this magnesium atom. So as a result, a dot and cross diagram will be developed. So the net positive charge is 2 plus, and the net negative charge is 2 minus. Overall charge is 0. So the overall charge should be 0 for the dot and cross diagram to be correct. Okay. Now the other dot and cross diagram is for Al2O3. So you know that aluminum's proton number is 13 and oxygen's proton number is 8. So the general configuration is like this, and general configuration is like this. Okay. So one aluminum will lose 3 electrons because aluminum has 3 electrons in the valence shell. One aluminum will lose 3 electrons, then the inner shell becomes the valence shell with 8 valence electrons. Now in the formula, 2 aluminums are present. So that is why I will place 2 here. So together, 6 electrons will be lost by 2 aluminum. One aluminum loses 3 electrons, so 2 aluminum will together lose 6 electrons. As far as oxygen is concerned, oxygen has 6 valence electrons like this, 1, 2, 3, 4, 5, and 6. So one oxygen will gain 2 electrons to get 2 minus charge. One oxygen will gain 2 electrons, but we have 3 oxygens in the formula. So we will place 3 here. So 3 oxygen together will gain 6 electrons. Okay, one oxygen will gain 2 electrons, but 3 oxygen together they will gain 6 electrons. So total positive and negative charge again is 0. And that is why this dot and cross formula will be taken as correct or will be considered correct. So in this way, you can deal dot and cross diagrams. For example, this is calcium Ca3N2, calcium nitride. So you know that calcium's proton number is 20. So general configuration of calcium is 2, 8, 8, and 2. And for nitrogen, the valence electrons is 7. So the general configuration is 2 and 5. So what happens that one calcium loses 2 electrons to get 2 plus charge. One calcium will lose 2 electrons, but we have 3 calcium atoms in the formula. So that is why I'm placing 3 here. So one calcium loses 2 electrons. So 3 calcium will lose 6 electrons. So total positive charge is plus 6. On the other hand, nitrogen has 5 valence electrons. So one nitrogen will gain 3 electrons to get 3 minus charge. One nitrogen will gain 3 electrons, but we have 2 nitrogens in the formula. So 2 nitrogen together will gain 6 electrons. So 3 calcium will lose 6 electrons and 2 nitrogen will gain 6 electrons. So electron loss and electron gain are equal. That is why this dot and cross diagram will be considered as correct. Okay, and now one more very important discussion is for hydrogen. Okay. With a hydrogen, you need to know that hydrogen makes ionic bond with metals. Okay, the rule is that hydrogen makes ionic bond with metals. Bond with metals. You need to keep this thing in mind. And the other thing is that hydrogen gains electrons when it bonds with metals. So hydrogen gains electron when it bonds with metals. Bonds with metals, right? Hydrogen makes covalent bond with non-metals, but hydrogen makes ionic bond with metals. So hydrogen gains electrons when it bonds with metals. So जब hydrogen electron gain करेगा तो it becomes 1 minus ion. And H1 minus is known as hydride ion. H1 minus is hydride ion. Hydride ion is represented like this. Hydrogen has 1 valence electron. लेकिन जब hydrogen gain करे 1 electron, तो इसके valence shell में will have 2 electrons. And this becomes H1 minus. Now this is hydride ion. So let us say dot and cross diagram of sodium hydride. So sodium loses 1 electron. Sodium has 1 valence electron. So sodium will lose 1 electron. So then this is the inner shell of sodium with 8 electrons. Okay. So sodium ने जो electron lose किया, hydrogen will gain that electron. And hydrogen becomes 1 minus ion. Now this is dot and cross diagram of sodium hydride. Now this is ionic bond. And an electrostatic force of attraction is present here, electrostatic force. NaH is ionic bond, right? And sodium is cation or hydride is the anion. So This is the concept that hydrogen makes negative ion, hydride ion, with when it combines with metals, तो hydrogen electrons को gain करेगा. Let's say अगर कहा जाए कि dot and cross diagram बनाएं calcium hydride का. So you know calcium has 2 electrons in its valence shell. So calcium will lose 2 electrons to make dipositive ion. So this is the inner shell of calcium then. And on the other hand, one hydrogen will gain 1 electron. Okay? One hydrogen will gain 1 electron, but you have 2 hydrogens in the formula, so that is why I place 2. So 2 hydrogen will together gain 2 electrons. So electron gain or loss either adjust over. Now once again, this is ionic bond. Calcium or hydrogen gain between ionic bond is there, or hydrogen is gaining electron. So this is the concept for hydrogen. कि जब metal से combine होगा तो it makes ionic bond. Okay. लेकिन जब हाइड्रोजन नॉन मेटल से बॉन्ड होगा तो हाइड्रोजन makes covalent bond with non-metals, right? Like HCl. Now H and Cl both are non-metals, so the dot and cross diagram will be like this because chlorine has 7 valence electrons. So this is how you need to make dot and cross diagram for HCl. So with non-metals, hydrogen makes covalent bond. Okay, hydrogen tend to share electrons with non-metals. Like for water, oxygen has 1, 2, 3, 4, 5, 6 valence electrons. So one hydrogen here and the other hydrogen here. So hydrogen is sharing electron with non-metals. So this was the discussion of ionic bonds.